Okay, right now we're going to look at some applications. And for me, what helps me with these word problems or applications are setting them up using a table. So you do not need to set up your problems the same way that I do, but it really does help me to organize it by setting it up in a table. So our first problem, Karen, a recent retiree, requires $6,000 per year in extra income. She has $50,000 to invest and can invest in B-rated bonds paying 15% per year or in a certificate of deposit, a CD, paying 7% per year. How much money should Karen invest in each to realize exactly $6,000 in interest per year? Okay, so in my table, I'm going to have a column for principal, which is amount that we're investing in each type of item, rate, interest, and then we have bonds, CDs, and we'll have total. So these are our column headings and row headings. So reading through the problem, Karen requires $6,000 per year, and that's total interest. So we'll put $6,000 under total interest. She has $50,000 to invest, so total principal is $50,000. Bonds pay 15%, and I want to write that as a decimal, so 15% is 0.15. CDs pay 7%, so 0.07. We want to know how much Karen should invest in each. So the principal that she invests in bonds and the principal that she invests in CDs. One of these you can make your X. One of them can be assigned your variable. I'm going to assign X to the amount that she invests in bonds. And I can define my variable just by putting it in the table here. So if she invests X dollars in bonds, then she must be investing $50,000 minus X dollars in CDs, because together those must add up to $50,000. Now to fill in the interest column in the table, I'll take principal and multiply it by the rate, because in general interest equals principal times rate times time, but here we're just looking at time of 1 year. So here interest will be principal times rate. So for bonds, interest will be 0.15 times X. And for CDs, the interest will be 0.07 times the quantity 50,000 minus X. Now this last column is where we will get our equation, because both the interest from the bonds and the CDs needs to add up to $6,000. So our equation will be 0.15x plus 0.07 times 50,000 minus x equals 6,000. And this is the equation that we will solve for x. So I'll start by distributing that 0.07 to the 50,000 and getting 3,500. And then 0.07 times x, we have minus 0.07x equals 6,000. Let's combine our like terms on the left-hand side. 0.08x plus 3,500 equals 6,000. Subtract 3,500 from both sides, and we get 0.08x equals 2,500. Divide both sides by 0.08. X equals $31,250. So that's how much money Karen needs to invest in bonds. To find out how much she must invest in CDs, substitute that amount in for X. So 50,000 minus 31,250, which gives us $18,750. Okay, our next problem. A tea manager decides to experiment with a new blend. She will mix some Earl Grey tea that sells for $5 a pound with some orange pekoe tea that sells for $3 a pound to get 100 pounds of the new blend. The selling price of the new blend is to be $4.50 a pound, and there is to be no difference in revenue between selling the new blend and selling the other types. How many pounds of each type of tea are needed? Okay, so this is a mixture problem. I'm again going to set this up using a table. And in my table, I'll have type, amount in pounds, price per pound, and then total cost. And for types, I'm going to use abbreviations. So EG for Earl Grey, OP for orange pekoe, and then new for my new blend. Okay, let's look to see what we can fill into the table. So we know that the Earl Grey tea has a price per pound of $5 per pound. And the orange pekoe tea sells for $3 a pound. And the store manager needs to get 100 pounds of the new blend. So 100 pounds will go under the total amount for new blend. So the new blend is to have a price of $4.50 per pound. And it says that there will be no difference in revenue between selling the new blend and selling the other types. That means that there's no profit that we need to take into consideration in writing our equation. So we do need to figure out how many pounds of each of the new type of tea are needed. So one of these I'm going to make X. I chose to make Earl Grey. The amount of Earl Grey tea my X, but you could have chosen to make X be the amount of orange pekoe. And if X is the amount for my Earl Grey, then 100 minus X is the amount for my orange pekoe. Because the amount column needs to add up. X plus 100 minus X does equal 100. To get my cost, I will multiply amount times price per pound. So for Earl Grey, we have 5X. For orange pekoe, we have 3 times 100 minus X. For the new, we have 4.50 times 100. And then this last column will give us our equation. So our equation is 5x plus 3 times 100 minus x equals 4.50 times 100. Okay, let's start by distributing the 3 to the 100. So we have 5x plus 300, and then 3 times negative x, so we have minus 3x, equals 4 times 50 times 100 gives us 450. On the left-hand side, let's combine like terms. So 2x plus 300 equals 450. We'll subtract 300 from both sides. 2x equals 150. Divide both sides by 2. And x equals 75. Remember, x is the number of pounds of Earl Grey tea we are mixing. So for Earl Grey tea, the store manager needs 75 pounds. For the orange pekoe, we'll do 100 minus 75, or we'll need 25 pounds. So if you're doing a table, you can actually indicate your final answers by filling in the parts of the table like I just did. If you're doing it a different way, you'll need to be specific in answering the question that for Earl Grey, the store manager will need 75 pounds, and for orange pekoe, 25 pounds. Okay, a third problem. A motorboat can maintain a constant speed of 16 miles per hour relative to the water. The boat travels upstream to a certain point in 20 minutes, while the return trip takes 15 minutes. What is the speed of the current? So again, I'm going to set up this distance problem, in this motion problem using a table. So I have a direction column, rate or speed, and the units for this will be miles per hour because that was given to me in the problem. Time. Now if I'm using miles per hour for my speed, then time will need to be in hours. So we'll have to be careful of our units. And then D, which should be miles, because if we're using the rate of miles per hour, distance should stay in miles. Okay, we have two directions. We will have our motorboat going, well, we know our motorboat is going 16 miles per hour relative to the water, and it's going upstream and returning downstream. So upstream is a direction and downstream is a direction. Now, for our speed, we're going to have a combination of what our motorboat is going relative to the water, which is that 16 miles per hour, combined with the current. Now, when we are going upstream, we're going against the current. So the current will slow us down, and we will need to subtract the current speed, which is what we're trying to find. So the speed of the current will be our x. And our speed upstream will be 16 minus x. Our speed downstream, because we're being helped by the current, will be 16 plus x. Okay, now upstream, it takes 20 minutes. But remember, our units to be consistent needs to be in hours. So 20 minutes over 60 minutes, which is how many minutes are in an hour, gives us 1/3 of an hour. Downstream, we have 15 minutes over a total of 60 minutes in an hour, which is 1/4 of an hour. Now, you may remember from physics that rate times time equals distance, and that's what we will use in order to get our distance values. So for upstream, we'll have 1/3 times 16 minus x, and for downstream, we'll have 1/4 times 16 plus x. Now the motorboat is going upstream to a certain point and then returning, so the distance will be the same. So upstream and downstream is the same distance. So we can use that to build our equation by setting the two distance expressions equal to each other. So 1/3 times the quantity 16 minus x equals 1/4 times the quantity 16 plus x. Now we could distribute and leave the fractions in there, but just like we've done before, we can identify the LCD. So 3 and 4 are our denominators, so our LCD is 12. So I can multiply both sides of this equation by 12. When I do that on the left, 3's cancel, and I'm left with 4 times 16 minus x. And on the right side, 4's cancel, and I'm left with 3 times 16 plus x. Now I can distribute. 4 times 16 is 64. 4 times x is 4x. 3 times 16 is 48. 3 times x is 3x. And we'll move our x's to one side of the equal sign and our constants to the other side. So I will move my x's to the right, and I will add 4x to both sides. I'll get 64 equals 48 plus 7x. I'll subtract 48 from both sides. So 16 equals 7x. I'll divide both sides by 7. X equals 16 sevenths. So that is the speed of the current, and that's miles per hour, and I will usually leave things in fractions. So that is what we are looking for. Okay, I did want to do another distance or uniform motion problem because I really do want to emphasize that I can't do every single variation on these problems, but you do need to be reading these carefully to be able to identify what you're given and what you need to find. So in this problem, a motorboat heads upstream on a river that has a current of 3 miles per hour. The trip upstream takes 5 hours, and the return trip takes 2.5 hours. What is the speed of the motorboat? So here, we are given the reverse in terms of the speeds. We are trying to find the speed of the motorboat, and we're given the speed of the current. So in my table, I still have direction. We have speed or rate, which is in miles per hour again. Time, which we'll keep in hours to be consistent with our rate. And distance, which will be in miles again to be consistent with our rate. Okay, we have upstream, and then we have downstream. So the current has a speed of 3 miles per hour. So remember, this is what will be added to or subtracted from the speed of the motorboat, which is what we're finding. That is what our x will be this time. So here, x is the speed of the motorboat. So for upstream, where we're going against the current, our rate will be x minus 3. And we're told that it takes 5 hours to go upstream. The return trip takes 2.5 hours, and its rate will be x plus 3. And we'll, just like before, rate times time equals distance. So our distance for upstream is 5 times the quantity x minus 3. And our distance for downstream is 2.5 times the quantity x plus 3. Again, our distance is the same, so we can set the distances equal. 5 times the quantity x minus 3 equals 2.5 times the quantity x plus 3. Distributing, 5 times x is 5x, 5 times 3 is minus 15, 2.5 times x is 2.5x, 2.5 times 3 is 7.5. I will move my x's to the left, so I will subtract 2.5x from both sides. So 2.5x minus 15 equals 7.5. I'll add 15 to both sides. 2.5x equals 22.5. Divide both sides by 2.5. X equals 9 miles per hour. So the speed of the motorboat is 9 miles per hour. If you're given a distance, remember you can still use the rate times time equals distance equation and rearrange it to figure out an expression for time. For example, time could equal distance divided by rate, or distance divided by speed. So you do need to carefully read your problem and use what you're given. Our next problem, Todd can deliver his newspapers in 30 minutes. It takes Tracy 20 minutes to do the same route. How long would it take them to deliver the newspapers if they worked together? I'm going to set up a table again, but it will look a little different. So we have person, we have time in minutes to do the job. And here it's minutes, but it'll be whatever time units you're given for your problem. And then our last column, our third column, the part of the job done in 1 unit at a time, or in this case, in 1 minute. So for people, I've got Todd, and Todd can deliver his newspapers in 30 minutes. So that will go in the time to do the job. Tracy takes 20 minutes. Now, if it takes, and then we will eventually have a together column. We don't know how long it will be, our row. We don't know how long it will take to do the job. That's if they work together. That's what we're trying to find out. That could be your x, or in this case, I called it t. And if it takes Todd 30 minutes to do the whole job, the part of the job he can do in 1 minute is 1/30th of the job. Similarly, Tracy can do 1/20th of the job in 1 minute, and together they can do 1/t of the job in 1 minute. The last column is what we'll use for our equation. 1/30 plus 1/20 equals 1/t. I'm going to get rid of my fractions by identifying my LCD, which in this case will be using 30, 20, and t, and our LCD is 60t. So that is what I will multiply the entire equation with. So moving on, we're just moving everything in this, or multiplying everything in this equation by 60t. When I do the first term, 30s cancel out, and we're left with 2t. 60t times 1/20, 20s cancel out, and I'm left with 3t. And on the right-hand side, t's cancel out, and I'm left with 60. So 2t plus 3t equals 60. Combining like terms, 5t equals 60. Divide both sides by 5, t equals 12. So it will take 12 minutes if they did the root together. One last problem. How much water should be added to 1 gallon of pure antifreeze to obtain a solution that is 60% antifreeze? Again, I'm going to use a table. So I'm going to have substance, amount, percent of antifreeze, and amount of antifreeze. So first, I have pure antifreeze, and we're told that we have 1 gallon. So our amount is in gallons, and I have 1 gallon of pure antifreeze. And it's pure antifreeze, so it's 100% antifreeze. Or as a decimal equivalent, 1. And our amount times the decimal equivalent will give us the total amount of antifreeze in gallons. So in this case, we have 1 gallon of antifreeze. We also want to have in the end a solution that is 60% antifreeze. So it's a mixture, a 60% solution. So, and we want to know how much water should be added to that, which has no antifreeze in it. So the amount of water, which is what we're looking for, is what I'm going to make my x. So for my mixture, our total amount of that mixture will be 1 plus x gallons, because I have the 1 gallon of pure antifreeze plus x gallons of water. So we're told it's a 60% antifreeze mixture. 60% as a decimal is 0.6. So the amount of antifreeze in this mixture is 0.6 times 1 plus x. Okay, now, again, this last column is what we're using for our equation. And we know that we cannot create antifreeze out of nothing. So these two values need to be the same. 0.6 times the quantity 1 plus x must equal 1, because we started off with 1 gallon of antifreeze. We're only adding water. We should still have 1 gallon of antifreeze in the total mixture. Let's distribute. 0.6 times 1 is 0.6. 0.6 times x is 0.6x, and that equals 1. I will subtract 0.6 from both sides. 0.6x equals 0.4. Divide both sides by 0.6. And x equals 2/3, because I prefer leaving things as a fraction versus a decimal. And this would not be a terminating decimal. So x is the number of gallons of water. We would need to add 2/3 of a gallon of water to the pure antifreeze to obtain a solution that is 60% antifreeze.